In this video, I'd like to showcase some simple but effective ways to backdoor a GitHub repository. So in the situation where an ethical hacker or penetration tester might be able to maintain persistence via some unconventional ways. In this scenario, the ethical hacker might have gained access to a developer machine or development computer where there are GitHub repositories pulled down and accessible. As an example, I'll be working with this test repo that I prepared on GitHub. Now, this is just for educational purposes and our learning, and your mileage may vary. But say that an ethical hacker landed on a box where there is that repository cloned and accessible. If I, acting as that ethical hacker, had gained access to this machine and were able to work with the test repository, we could do a couple different things. The first thing I'd like to show you is making use of Git hooks. And this is a page from their documentation. Like many other version control systems, Git has a way to fire off custom scripts when certain important actions occur. There are two groups of these hooks, client-side and server-side, but client-side hooks might be more interesting to our purposes. Client-side hooks are triggered by operations such as committing and merging. You can use these hooks for all sorts of reasons, and we'll leverage them for some ethical hacking and trying to backdoor a GitHub repository. Hooks are all stored in the hooks subdirectory of the Git directory. For most projects, that is .git/hooks. And I'm sure you know that inside that .git folder are all the Git internals for working with the version control system. Of course, the .git folder is a hidden directory with the preceding dot or period. If we were to open up that .git/hook subdirectory within a text editor, we could see a lot of the examples that they've already provided. They include some .sample files that showcase some of the syntax and things you could do for different events. Of course, you can do this in any scripting language that you'd like, but bin.sh or simply bash or zshell is fine for a Linux system. To enable a hook script, you simply put a file in the hook subdirectory with that .git folder that's named appropriately without any extension. That means the file name is very important because it has to match the event or trigger that you're actually looking for. And there are a lot of client-side hooks. Their documentation showcases the pre-commit hook alongside the prepare commit message hook. They also have the commit message hook and the post-commit hook. There are many others, and if you actually scroll through the documentation, you can see a lot of other examples. Also, let me please emphasize the note here, client-side hooks are not copied when you clone a repository. For that reason, this is best done when you have local and interactive access to the victim machine, like a compromised developer box. You won't be able to push these changes and have them persist for a repository that will be cloned down repeatedly. So again, your mileage may vary with this trick, but I think it's worthwhile to know. You can, of course, hook onto any of these actions, but if we wanted to create our own for some of that offensive security or ethical hacking purposes, let's try to create one for the pre-commit event. I'll create a new file and simply save this as pre-commit. From there, we can basically define our own script to run and invoke as the git commit command is ran. So let's add in our shebang line as usual, and let's try to simply echo pre-commit hook fired. I'm using an exclamation point in this output, so I do want to be sure to use the single quotes to define our string. And with that saved, now we'll need to make sure we mark this script as executable. Back on our command line, let's chmod +x to add the executable bit to our git hooks pre-commit script. Now, without even needing to make any changes to any files or even adding its own commit message, just simply typing git commit will spawn and invoke that script. You'll see the output pre-commit hook fired. But let's make this a little bit more ethical hacker friendly, and let's try and get a reverse shell to our attacker machine. So on the right-hand side of the screen, I'm going to take a look at my current IP address for my ETH0 network interface. Locally, that IP address is 192.168.88.167. We can copy that value, and then let's start listening to host and serve on a port with Netcat. To keep it simple, I'll use port quad 9 or 9999. Then, as we listen, we can prepare a reverse shell syntax to make sure our now pre-commit hook will actually start a callback to our attacker machine. To make things easy for us, we can use the online resource revshells.com to easily generate the syntax for a reverse shell. We'll enter our IP address and the port that we want this to connect to, quad 9. Now it provides the syntax down below, but I like to use bash to make sure this invokes and executes properly. So back in our pre-commit script, let's remove the previous echo line and then paste in that reverse shell syntax. Now I like to wrap this with bash tac c, so it's executed within bash, and we can use bash tac I to make sure that this is all triggered as we'd expect. Personally, I like to background this task with another ampersand just before our closing single quote, to denote the string. Once we save this file, it is still marked as executable. So running git commit once again in our terminal should get a callback. Now, anytime the developer commits or makes changes in this repository, it will spawn a reverse shell connection. And they don't see any suspicious output or anything worrisome on their side, but on the attacker side, now they have access in the environment. It's a persistent callback leveraging git commands. Now, of course, we have not done any obfuscation or tried to mask or hide this whatsoever. You can get creative if there is anything you'd like to do to try and decorate or hide this syntax, and you do have this leftover artifact on the file system with the pre-commit file and hook script itself. These are all things you should know for OPSEC, but I think it's still a worthwhile trick in your toolbox. And there's nothing stopping you from experimenting with other Git hooks, or other opportunities to do some interesting persistence mechanisms for ethical hacking. Another trick you might be able to leverage is using Git aliases. And these, just like aliases as you're used to on the Linux command prompt or other shells, are meant to add a quick and easy nickname or friendly name for commands you typically run. You can configure aliases with the simple git config command as you see the syntax here, or you can simply add them to your .git/config file. By default, git aliases are meant to be running other git subcommands, but we can use this feature to actually run any external command we'd like, and get a reverse shell, add a backdoored user, exfiltrate information, anything that you'd like. All we need to do to use that capability is include a exclamation point prefix before our command syntax. So just to experiment, let's close out of the reverse shell that we had on the right-hand side of the screen and start another listener. Then, as if we were on the victim machine, acting as the attacker, let's try and make changes to our .git/config file. You might be used to the syntax here with the sort of square braces to denote a new section of the configuration, but if we were to add our alias section, we could add maybe yet another alias for the commit subcommand. We'll include the exclamation point for our usual external command, and let's grab the same bash reverse shell syntax that we used just previously with the git hooks. While we're here, let's comment this out so it won't actually fire as we're testing the new aliases. Let's paste it into our .git/config file, and we are a-okay to be using these single quotes nested inside of double quotes here, but let's try this. Back at the command line, after we've made changes to those files, trying to run git commit, well, we don't see our callback. There is one important gimmick and gotcha here, in that Git will not let you set an alias for an already existing subcommand or keyword you'd typically use with Git, like git add, git commit, or git push. With that said, it's easy to come to the conclusion that, oh, this isn't all that useful. But I think it's something that you could still leverage with typos. How often do you accidentally mistype a command on the command line? We could certainly change this commit with 2 M's to just 1 M. Or add as many others as we'd like for git add, but maybe missing the second letter D there. Say you forgot to add the last letter to the push command, and any of these as sort of typo squatting command prompt syntax, we could still stage a reverse shell. Of course, obfuscating this and masquerading as you might like. Now, no changes. Let me say that I accidentally mistyped git commit, and we've got our reverse shell. You might still need to do a little bit more decorating because, well, it's not going to error as it normally does when you have an accidental real mistake. We could simply use echo or printf to display this just as easily, but at the end of the day, we get our callback in reverse shell. Small, simple tricks, but we've successfully backdoored, so to speak, a GitHub repository. If you ever land on a developer machine acting as a developer account, it's worthwhile to try this. And again, you can get creative. Maybe you backdoor the git binary on its own, or set an alias for the git command, or you package up an entire repository in a .zip archive that maybe you pass to another user for a quote-unquote internal repository. There are a lot of clever things you can try, but ultimately, I think the whole idea is trying to backdoor or add persistence mechanisms to usual, natural, and native capability in a Linux environment. By the way, a part of this demonstration is actually part of one of the lessons inside of my latest Linux for Hackers Fundamentals course that we're putting out with Hacking Hub. If you haven't seen it, hey, it is available for pre-sale right now. You can find it online at hackinghub.io, and I really hope you take a look. Let me emphasize, this is a course on the fundamentals, but with an ethical hacking flair. You'll learn a little bit more about backdooring or adding persistence mechanisms and doing some post-exploitation, persistence, and privilege escalation tricks. I'll include a link in the video description, but if you're interested, I really hope you take a look at the Linux for Hackers Fundamentals course from Hacking Hub. With all that said, thank you so much for watching this video. I hope you learned a couple tricks that maybe you haven't heard of before, or you got some ideas for how you can use this in your own ethical hacking or penetration testing purposes. Please do all those YouTube algorithm things, like, comment, subscribe, and I'll see you in the next video.